Hi, welcome to this video where we're going to be dealing with tangents and normals. This is the second video in the differentiation series that we're looking at. Pretty quick one, we've just got two examples we're going to look at here. A tangent is a line that just touches a curve at one spot. That's the blue line you see there. And a normal is a line that is perpendicular to the tangent. So it goes through the same point on the curve, but it's at 90 degrees to the tangent. So going back to a little bit of stuff that we did in coordinate geometry, we know that the relationship between a line and its perpendicular is that one gradient is the negative reciprocal of the other. So this thing here is important. We're going to be using that. So here's the process that we're going to go through. To find the equation, we're going to differentiate the function. Remember, the derivative is telling us about the slope of the curve or the slope of a tangent. We're going to substitute in the given x value to find the gradient, and then substitute that x value into the original equation to find the y value, if we're not given it, and then go back to our coordinate geometry skills to use the equation of a line, y equals mx plus c, to substitute in the point and the gradient to find c, and hence get the equation of the line. So first example, we want to find the equation of the tangent and normal to this curve, x plus 4 over x, at the point where x equals 1. Now, you're not expected to know how to draw that curve, just got to know the calculus to get it. So to do the derivative here, x plus 4 over x becomes x plus 4x to the minus 1. Remember, to do the derivative we need the x's on the top line. So the derivative is, okay, that is 1x. So the derivative of any term with x in it is just the coefficient of the x. So that's just 1. Number down the front here, minus 4x to the minus 2. Subtract 1 from the power. X to the minus 2 becomes x to the plus 2 on the bottom line. So there's the formula for the derivative, or the slope of the curve, or the slope of the tangent. Okay, we want to know what the slope is when x equals 1. So I substitute 1 into that equation, giving me minus 3. So there's the slope of the tangent. I also want to know what the y value is here. So when x equals 1, substitute 1 back into the original equation, giving me 5. So we've got a point on the curve, we've got the gradient of the line, and so therefore we can work out the equation of the line. Y equals mx plus c, so I replace m with 3, I replace x with 1, and I replace y with 5, giving me this. Sorry, I replace m with minus 3, that's right. Okay, so if I work that out, c is equal to 8, so the equation of the tangent is minus 3x plus 8, or if we write it like this, 3x plus y minus 8 equals 0. If the gradient of the tangent at that point is negative 3, then the gradient of the normal is a third, the negative reciprocal. So then we go through the same process, y equals mx plus c, it's the same point, 1, 5, and for the gradient I put a third. That gives me c is 14 over 3. If you like, you could call that 4 2/3. Call it 14 over 3. So the equation of the normal is y equals mx plus c. We've got the gradient, third, we've got the value of c, there it is there. If we multiply everything by 3 and rearrange, we get this equation here. If the question just asks you to find the equation and doesn't specifically say to put it in this form here, then it's fine to leave it like this. Here's a picture. Here's the curve, x plus 4 over x, that's the red line. There's the tangent there in green, and there's the normal in blue. Okay, second example here. The normal to this curve, g of x, kx minus x squared at x equals 2, has a gradient of a half. Okay, we want to find the value of k first. Okay, this is a little bit trickier. So we've got a constant in the equation here that we don't know, but I'm already telling you what the gradient is. And I've given you the point that this is happening at. Second part of the question, the normal intersects the curve again at the point P, find the coordinates of P. Right. Okay, so for the first one, let's look at the derivative. We're talking about gradients of curves, so if it's mentioning gradients or slopes, you know you're going to have to do the derivative. So the derivative kx is just k, the number in front of the x, and the derivative of x squared is just 2x to the power of 1, or just 2x. So there's the derivative. We're told that the slope, that's this thing here, k minus 2x, The slope when x equals 2 is equal to a half. No, it's the gradient of the normal. Okay, so if the gradient of the normal is a half, we're talking about the gradient of the tangent being minus 2, the negative reciprocal. So when x equals 2, when we substitute 2 into this, we're going to get minus 2. So I've done that, substituted x for 2, giving me this. K minus 4 is minus 2, so k equals 2. There we go, we've got 2 for k. For part B, it's good to see a picture of what's going on here. Once again, you don't have to draw this, but here we've got g of x, it's a parabola. We've got the normal to the curve at the point x equals 2, there it is there, that's that blue line. We just worked out that k equals 2 in that equation. Now I want to know what's the coordinates of this point over here where it intersects the curve again. So basically I want to find the intersection between this line and this curve. So I've got the equation of the curve, I want the equation of the line. So first part is I want to work out the equation of the normal to the curve. Remember, to find the equation of a line you need two things. You need the gradient of the line and you need a point on the line. So the gradient, first of all, we're told in the first part of the question that the gradient is a half. So I've got that, I know the gradient. We know a point on the curve, we at least know that the x value is 2 we're talking about. So what's the y value? The y value when x equals 2 is, substitute 2 into the original equation and we get 0. So as you can see from this little picture here, the y value is 0. So we know the x value is 2, the y value is 0, the gradient is a half, substitute that all in and we get c equals minus 1. So here's the equation of the line. Y equals a half x minus 1. So to find the other point we just solve simultaneously. A half x minus 1, that is the blue line, equal to 2x minus x squared, that's the curve. Times everything by 2 to get this step. Rearrange to get everything on one side equal to 0. We've got a quadratic, which we can then factorise, giving me x equals negative a half or 2. I already know that x equals 2 is one point of intersection, so the other one must be x equals negative a half. Now we want the coordinates, so we can't just leave it with the x value. We have to find the y value. So I'm going to substitute minus a half back into the original equation, okay, which is 2x minus x squared. Put that into my calculator, it gives me minus 1 1/4. So there's the coordinates of the point P. Minus a half, minus 1 1/4.